Welcome to the class. Today we will be doing part 9 of One Rule One Page series where we will solve some questions. Rules or properties we have done already till part 8. Today we will see how to apply it. So what topics we are going to cover? We are going to cover these 5 topics. Let's see one by one. First topic is simplify exponents to the power of 0 where the power is 0. For example, let's see the first one, power is 0. Whenever the power is 0, it is always equal to 1, right? Whatever the number is. Here, the number is negative, even then it is equal to 1. Here, the number is in fraction 1 by 2, even then it is 1. Variable, it's okay, even then it is equal to 1. Here I have product of 2, 5 and then x cube, but this is the overall power 0. Overall power is 0. Then it is equal to 1. Now this is a combination of terms and every term has power 0. This term has power 0, this term has power 0, this term has power 0. All the terms, different terms have power 0. So we will apply the same rule. This negative 3x to the power 0, this is the whole power, so it will be equal to 1, then positive sign, and then 9 over z to the power 6, it's okay, whatever the power is. As the overall power is 0, it will be 1, and negative 3 over x, this negative sign will be here as it is, and this whole power is 0, this will be 1. So this is 2 minus 1, which is 1. So whenever the power is 0, it's going to be 1, no matter what the base is. Now let's do simplify exponents involving 1. That 1 can be power or 1 can be base. 1 can be here as a base or 1 can be here as an exponent, right? So in both the cases, let's see what happens. Whenever it has power 1, it will be number itself. Why? Because negative 5 is multiplied, the number itself. So it will be negative 5. 6 raised to power 1 is 6. 1 by 6 raised to power 1 is 1 by 6 itself. Now here we have negative 1, which is a negative exponent. So this is not equal to minus 1. Here first we will apply the reciprocal rule. So that will be negative 1 over 5. Whenever we apply the reciprocal rule, we never change the multiplication sign rule. For example, here it is negative 5. That will not be affected during the reciprocal rule. Yes, overall negative 1 power has become 1 now. So this answer is negative 1 over 5. So whenever we have power negative 1, we simply reciprocate it. It's 1 by 6 raised to power 1. And it's negative 1 over 5 raised to power 1. So yes, now we have converted our question into power 1, and as per this rule, that will be the number itself. Now what if 1 is as the base and it has power x or power negative, or let's say one question where the power is positive? Point is, if you multiply 1, every time the result will be 1. No matter how many times you multiply it. So your answer is always 1, right? Let x be 3 here and we are multiplying 3 times. Now let's see, it's a negative exponent and I am just reciprocating it. Now it's positive. See, it's not at all affected. So now how many times you multiply, the overall result will be 1 every time. And now here I am multiplying 1 5 times. It's okay. 1 times 1 times 1, 1, 1, this is 1. Okay, next topic, third topic is simplify exponents with base 0. So whenever base is 0, you have 0 to the power 6. 0 is multiplied 6 times. It will be 0. 1, 2, 3, 4, 5, 6. It will be 0, right? Now it has a negative exponent. So that means first I have to make it positive, right? So I have to reciprocate it. 1 over 0 raised to the power 6. Now 1 over 0 is not defined, right? So no matter how many times it's being multiplied, it will be 1 over 0 and that will be not defined. So if 0 has a negative power, make it positive first, reciprocate it, and then that will be not defined. But if it is a positive power, then it is 0 always. Sometimes we have 0 to the power k, but it's different in different fields of mathematics or other studies we do. So let's leave it here. Now let's simplify exponents using multiple rules in one question. Let's see what should be the sequence of the questions which we are doing. It's 4z cubed. So first we will apply power of the product rule, or product. This 3 is to be distributed to both 4 as well as z, right? So this will become 4 cubed z cubed times z to the power negative 8. Now we see here we can apply the product rule because bases are same, z and z. 4 is not the same base, so we will apply product rule only for z. Z to the power 3 times z to the power negative 8. Rule says when bases are same, powers are added. So this will be equal to 4 cube times z to the power 3 minus 8, which is equal to 4 cube z to the power minus 5. Now there is one more condition, that our answer should be with positive exponents only. If that is the case, then I have to reciprocate this z to the power 5 to make it positive. So it will be in the denominator now. I have expressed my question in exponent form itself, but if you have to evaluate, listen carefully, if you have to evaluate, that means you have to give the value of 4 cube to, which is 4 times 4 times 4, which is 64 over z to the power 5. So this answer 4 cube over z to the power 5 is actually the answer in the positive exponent form, right? This 64 over z to the power 5 is, I have evaluated the whole thing. And this is, if you have to answer and it does not matter your answer is in positive exponents or in negative exponents. So you have to see these 3 ways. All the 3 are correct answer, just the different versions of answer. Question 1 done. Now let's come to question number 2. Here again, 5 is a power to both 2 as well as x. So I'll distribute this power first. So that will be 2 x to the power 5 times x to the power 2. Now here we have x and x as the same base. 2 is not the same base. So it will be written as it is. And in the case of same bases, powers are added. So this is 2 x to the power 7. Perfect. Now let's come to next question. Next question is, okay, it's power of a power rule where we simply multiply the two powers. This is negative 3 times negative 3, right? And this is the second one. Here first we have to distribute, right? Let's see, we need our answer in positive powers, but let's start from here. So it's 2 to the power negative 3. This is one way that you distribute it first, times k to the power 5 times negative 3. Here I am applying power to power rule to all the 3 factors, right? 5 times negative 3, z times negative 6 times negative 3. So I have distributed power to them separately, to 2, to k and to z, all of them. Now let's solve them. It's negative k to the power 9 times 2 to the power negative 3 times k to the power negative 15 times z to the power 18. Now it has become an interesting question. Why? because it's negative k raised to power 9 and it's k to the power negative 15. So you must be thinking what should be done with this k. This is a negative sign, it's multiplied. It can be here, right? Multiplication is commutative. If you know, if you multiply 3 times 4, it will be 12, or if you multiply 4 times 3, it will again be 12. So it does not matter what sequence is there in the multiplication. So I can adjust the terms. I'm adjusting, grouping them as the like terms together. So 2 raised to power minus 3. Minus sign is here. It is commutative, so it can be here. Now I am arranging all the terms with k. There are only two terms. And then the term with z. So negative, because I have to answer my question in positive exponents. So this 2 to the power negative 3, this negative will not be affected. Why? Because this is in multiplication, not in the power. So it will become negative 2 over 2 to the power 3, correct? Now k to the power, I'll apply product rule over here. 2, 9 plus minus 15 times z to the power 18. Now let's go further. 2 cube is actually 2 times 2 times 2, which is 8. And let's see k to the power 9 minus 15, which is negative 6 times z to the power 18. Now the condition is that the answer should be in positive exponents only, and k has a negative power, negative 6. So I have to apply reciprocal rule over here. So that will become z to the power 18 in the numerator, right? Because this is the only positive power here, and that will become 8 k to the power 6. Now when you are revising this question, stop the video, revise it, see how we are managing the negative sign. That is really important, okay? Where we have to, wherever we are applying the reciprocal property, only the sign of the power is changing, not the sign which is in the multiplication. Take care of this thing, okay? Now this is our next question. First I have a overall power, right? Every 2 is different, n is different, b is different, so nothing can be done. But one important thing in this question is that this negative sign will also have the power cube. This is really important. Whenever we are giving sign power to every number, don't forget to give it to sign 2. So this will be 2 cubed times n to the power negative 4. Here we are applying product of the power rule, and then b to the power negative 3 times 3. So now we are sure that we have given power to every number as well as sign every variable. Now let's see this negative. When negative sign is multiplied odd number of times, the result is negative. So negative 2 to the power 3 is 2 times 2 times 2, which is 8. But if I need to answer my question in exponents form also, so leave it as it is, times n to the power 4 3s are 12 over b to the power negative 9. Let's check, are we correct? Yes. Now our answer should be in the positive exponents. Should I consider negative 2 to the power 3? Stop and think. No, we will not, because it's negative in multiplication, not in power. So here it will be as it is, negative 2 to the power 3. Now reciprocal rule will be applied to n. It is in numerator, it will be in the denominator, and b to the power minus 9 is in the denominator, it will come in the numerator. Perfect. Just stop, revise it a little bit, and then, okay, let's do one more question. Let's make a question like 2x to the power 4, y to the power negative 4, z to the power negative 3 over 3x squared, y to the power negative 3, z to the power 4, and let's make it negative 1, whole power negative 1. Now I'll stop for a while. Think, what should I do? If I need to make this positive, right, I need to reciprocate the whole thing. Reciprocation is like if 5, its reciprocal is 1 over 5. If it is 1 over 5, its reciprocal is 5. If it is 3 over 5, its reciprocal is 5 over 3. So if we have both numerator and denominator, they can interchange their places, right? And if I do this negative power with it, it will become 5 by 3. So suppose you have x over y raised to the power minus 1, you will simply reciprocate it and this power will become positive. Even if it has x by y raised to the power negative 2, you will reciprocate it as y by x and make the power 2, right? So we will apply this in our question and let's do. So it's a better idea that first we convert the power as negative 1, but it's totally fine if you do it other way too. Let me do it with both ways. First, I am not touching negative 1 power, I am leaving it as it is and then applying the rules. So 2 by 3, these are the numbers. Okay, this is in fraction form. Now x4 by x squared, this is like quotient rule. So powers are subtracted, this will become 4 minus 2. And then minus 4 and denominator is minus 3. So negative 4, negative of negative 3 times z to the power negative 3, negative 4 whole to the power negative 1. So this is 2 by 3 x to the power 2 times y to the power negative 4 plus 3 negative 1 z to the power negative 7 whole to the power 1. Now let's reciprocate it. So this will become 3 by 2. X square is in the numerator, it will become x squared, and y to the power minus 1, so it will become 1 minus 1 because I have to reciprocate it. Now when I am reciprocating, sign of the power is not at all affecting, right? And it's z to the power negative 7. Now it has become 1. Now don't you think it's a little bit like tricky? We may make mistake. So it's better first you give power to individual terms, right? Like 2 by 3, 2 to the power negative 1, x squared to the power negative 1, then y to the power negative 1 times negative 1, then z to the power negative 7 times negative 1. I mean, that is totally your wish. How you are comfortable, which property you want to apply first, which property you want to apply second. So that will be 3 by 2. Now this is x to the power negative 2, power rule. Y to the power negative 1 times negative 1 is 1, and z to the power negative 7 times negative 1 is 7. Now only x is there, which is a negative power, so it will become 3 by 2 x to the power, okay, I need to reciprocate it because I need to answer my question in positive exponents, y times z to the power 7. This is one way. Now if you think that okay, let's reciprocate it first, believe me, it's not going to affect your answer. Let's reciprocate it. 3x squared, I am doing it with the second method. 3x squared y to the power negative 3 z to the power 4 over 2x4 times y to the power negative 4 times z to the power negative 3. The important point is here is that whenever you are reciprocating, don't change sign of any of them because you are reciprocating due to this negative one. So inner terms will not be affected at all. They will go as it is, right? Do you think so? Just stop for a while and think. Now this is converted. Overall power has gone, so we do not need to write -1 every time. So according to me, it's a good idea because we do not have one power and we are feeling much comfortable that one of the power is totally gone. But if this is your style, you can do it this way. Now I will apply. I'm seeing each term in a different way. Numbers with numbers, exponents with exponents. So this and now this is y to the power negative 3, negative of negative 4, z to the power 4, negative of negative 3. So this is 3 by 2 times x to the power negative 2, y to the power negative 3 plus 4, 1, and c to the power 7. So now I need to answer them as positive exponents. So y and z are already positive. This x has a negative power, so it is in numerator. So I'll just move it in the denominator. So see, in both ways my answer is same. So just you have to take care of the fact that you are applying the properties correctly, but otherwise if your sequence of applying the property is different from someone else, it's okay. If you are applying it correctly, your answer will be the same, right? Okay, now let's see our last heading, where we will find the value of the variable. Okay, suppose this is my question, right? And I need to find the value of the variable. So first rule is, let's see the rules first. Suppose I have 3 to the power 6 is equal to 3 to the power 7, right? So I need to find the value of a. So because the bases are same and they are on the opposite side of the variable, so a is equal to 7. We can equate the powers. This is rule number 1, right? First rule, we are going to apply this. Yeah, that is important. Bases should be same and they should be on the opposite side of the equal to sign. Now second rule is, we have already learned it, but let's revise it. Suppose I have something inside v sign. I said it, it's not a language which should be like very mathematical, but sometimes we use language which is easier to understand because finally we have to solve the questions. So if we have n inside, and there is some number, say a, and it has power m, so it is the nth root of a to the power m. So how will we write it? We will write it as a to the power m over n. So I'll use these two rules and solve this question. So 3 to the power a is equal to 3 squared whole to the power 1 by 4, or 3 to the power 2 by 4, or 3 to the power 1 by 2. So 3 to the power a is equal to this. Now we have reached to a step where bases are same on both the sides, and I have 3 to the power 1 by 2. So value of a is equal to 1 by 2 here. We can write it. Why? Because we have the same base 3 and it is on the opposite side of equal to sign, right? This is the last rule. So yeah, definitely you have to practice a lot for exponents, because just by doing 3 or 4 questions, you are not going to get perfect in this. You have to practice a lot. But if you see these rules and practice these questions, definitely you will get some clue how to solve this. So keep practicing, and because now you know how to solve the questions, so let's give ourselves a big smile because now we know exponents, and goodbye.